All right, good evening, good afternoon, good morning. Mr. Gubino here. We're going to go over AP Calc Units 1 through 7 grab bag from the AP Live, from the awesome teachers that are doing the AP Live. And a couple of these questions are on the video that they've done that I've posted. So I'm not going to go over those, but I will go over the ones that they did not go over. So we're going to get started here, and we're going to look at, let's see here. I have scene 3. Okay, so here we go. We're going to talk, they talked about number 1. They talked about the shift and this and this. So we're gonna skip that one. We're gonna go to this one. So differentiation. They actually talked about this one too, but I found it pretty interesting. They give you f of -3 is 5, and the slope at 3 is -2. -3 is at 2. They give you g, so g prime of x is -1 over x squared. Do that derivative if you don't know what you're doing. Okay. And h of x is this. This is the alternate formula for the derivative. Okay, so this is the alternate at a specific point. So the specific point is -3. So what we're going to do is we're going to take that, and basically this tells me that this is h prime of x, which is looking for h prime of -3. So that's what we're going to be looking for. All right, so I need the derivative of this. So we have first function, second function, derivative 4 f of x times the second derivative is g prime of x plus the second g of x times the derivative of the first, which is 4 f prime of x. And they want to know what h prime of -3 is. So 4 times f of -3 times g prime of -3 plus g of -3 times 4 f prime of -3. All right, so we got this. We need g of -3, which is going to be -1/3. And g prime of -3 is going to be -1/9, plugging in -3. So in this case, we get 4 times f of 3, f of -3, excuse me, is 5. G prime is -1/9, plus g of -3 is -1/3, times 4 times f prime of -3, which is -2. So what they say is that this is a totally acceptable answer because it's all numeric, but people like to clean it up a little bit, so we're going to clean it up a little bit. We're going to get 4 times 5 is 20, times that is -20 over 9. We're going to go plus 1 times 4 times -2. This is negative, so this is 8/3. And what we had to do is change that, so that would be what, 24/9, which gives me a grand total of 4/9. So that is that differentiation for there. So, hi. What I would do is pause the video if you want to go on to the next part and see where we're going. I'm going to go right into it, and we're going to go with Unit 3, talking about the chain rule. So in Unit 3, talking about the chain rule, we have this table, which talks about G, and we have this graph that talks about H. And we're talking about a function G is differentiable. So if it's differentiable, it is continuous. The table gives the values of G and its derivatives, and a function of H, whose graph is shown above, consists of 3 line segments. Let k be the function defined by k of x is equal to h of g of x. Find k prime of 1. This is a good chain rule problem, So we need k prime of x. That is going to be the derivative of the outside, leave the inside, times the derivative of the inside. So there is chain rule. And then we want k of -1. So we need h prime of g of 1 times g prime of 1. So we need h prime of, let's do this, g of 1. G of 1 is 2. So we need h prime of 2 times g of g prime of 1. So I'm going to go up here. H prime of 2 times g prime of 1. So h prime of 2 at 2, I need the slope, and that slope is a rise of 1 and a run of 2. So this is positive 1/2, and g prime of 1 is 0.2 or 2/10. And that's an easier way to write it. Or you can go 0.5 times 0.2. You can go 0.5 times 0.2, which is 0.10, which is 1/10. Either way, you get it. Okay, part B. Part B is an inverse function. I showed you a video of inverse functions, and this is what I came up with. So when we get the inverse functions, where are my notes that I took? There they are. All right, so this inside number is that number. So g of 4, excuse me, g of x is 4. Well, where's g of x 4? X would be at 2. So g of x is 4 at 2. So x is 2. So g of 2 is 4, means that since these are inverses, m of 4 is 2. So what they do is they switch their x's and y's. Now I want m prime, so I need g prime of 2, and g prime of 2 is 0.4, which is 4/10 or 2/5. And then what I get for m prime at 4 is I'm going to flip 5/2. So g prime of 2 is 2/5. So that is going to be 5/2. All right. Number 2, give the differential. If dw dt is this, find the second derivative. All right, so the second derivative is 1/10, and then the derivative of this in terms of t is going to be 1 times dw dt, because there's no t in there. So this is 1/10 times dw dt, which is up here as another 1/10 w minus 600. So the second derivative is 1/100th of w minus 600. Now that is going to play into the next two. I'm going to check B, but I think B is good. So we're going to go on to the next page. Okay, you might hear my son in the background here in a little bit, but I'm going to go yell at him here in a second. But here goes back to the problem. So at 2, 4, that's where G is. So M is at 4, 2. And if the slope is 2/5 for G, then it's going to be the reciprocal of that slope, which is going to be 2/5. Okay, so we're going to... Okay, so I did go yell at him. So, all right, so we're going to go back to the paper, and we're going to go on to the next page. And the next page is Unit 4 with contextual implications. So let's talk about that. So we have this, and what they're asking for. So if you notice, it's the beginning of the other problem. where the dw dt is 1 over 100 times w minus 600. Where w is measured in tons, t is measured in years from the start of 2020. Use a tangent line at the graph of w at t equals 0 to approximate the solid waste that the landfill contains at the end of April 2020, which is t equals 1/3. So we have a point, an initial point, and we have a slope. So dw dt is going to be 1/10 of 1500 minus 600, which is going to be 900 divided by 10 is 90. So my slope is 90. So we have y minus 1500 is 90 times t. I'm going to use t in this case. That could be w over here, minus 0. So y is equal to 90t plus 1500. And if you notice, that equation is always increasing. So at an approximation of 1/3, that's 90 times 1/3 plus 1500 is going to be 1530 tons through t equals 1/3. Okay, so that is how many tons are going to be in there. Now, in Unit 5, so that's the answer to Unit 4, that's the contextual application of the derivative. So at the beginning, they wanted you to find this in terms of w. Well, you did that on the previous page. So that is 1/100th of w minus 600. And then what we need to do is determine if the tangent line is an under and over estimate of that. So what we're saying is that because the landfill increases at a rate of it's an increasing function, with this is always increasing for w greater than or equal to 1500, because that's my initial amount of how much waste is in there. And if you look at the second derivative, or the tangent line, you're looking at a tangent line and you're looking at this graph. So what's happening is they want to know if that is increasing. So therefore, since the second derivative, which shows concavity, is going to be greater than or equal to 0 between 0 and t is 1/3, and you're looking at w always being positive, that rate is always going to be positive. So it's dw dt is increasing, is greater than 0, and this is increasing. Therefore, it's an increasing function, so the tangent line is going to be below. So if we look at the function, the tangent line is going to be below this function. So if they're asking for this, this is the underestimate. So the tangent line is going to be an underestimate because the derivative is an increasing function. The landfill is an increasing, everything's increasing, so everything increasing means it's going to be an underestimate. All right. All right. Number 2, verify that it is the mean value theorem. So I have g of x between the numbers of this. So I need that f of c, if you remember, is f of, g, and we'll go g. So this is g of 0 minus g of -2 over 0 minus a -2. So I need the derivative of this function, which is going to be 1 over 2 square root of x, 2 square root of x plus 2. Take it. We've talked about that one. The derivative of the square root of anything is 1 over 2 square root of x. Pay attention to what that is. Notice what happens. X to the 1/2. You bring it out front and decrease it. It becomes that. G of 0. So g of 0 is the square root of 2. the square root of 2 minus 2 is 0, over 0 minus a negative 2 is 2. So this is square root of 2 over 2. So what we're going to do is we're going to multiply by 2. So we get 1 over 2 square root of x plus 2 equal to the square root of 2 over 2. And now we need to solve this equation for x. Okay, so let's take this. I'm going to multiply by 2. And what that does is it gets rid of that. So we have 2 square root of x plus 2 is equal to the square root of 2. Now from here there's several ways in which you can solve that. I would probably multiply each side by 2. Multiply this by 2 square root of x plus 2. And then what you get, and if you can keep that over there. Actually, let's do that. Let's keep that over there. So these two multiply together. We have that multiplication rule with g of, square root of a times square root of b is square root of a times b. So in this case, we would have the square root of 2x plus 4. Okay, so if I square each side, I get 1/4 is equal to 2x plus 4. Square both sides. Subtract 4 minus 4. So 1/4 is minus 15/4. And if I divide by 2, I don't get my answer. Hold on. Where did I go wrong? Okay, I know where my mistake was. Over here, I forgot to divide by 2, so I am going to multiply by 2 here. I'm not going to look at that. So this is out. Okay, so we'll do this one over there. I'll cut off a sheet of paper here, and I'll post that in. Just a little edit. That's no problem. So we get 1 equal to the square root of 2 times the square root of 2x. X plus 2. Okay, it is getting late. So that is 2x plus 4. Square both sides is 1 is equal to 2x plus 4. 2x is equal to negative 3, and x is equal to negative 3 halves. That is your value that is between, and that is your c value. It is between negative 2 and 0. Unfortunately, I can't go back and cut that, so this is the good stuff. The other stuff is not the good stuff, okay? So when we get to this point, we're going, I forgot the divide by 2, and when I multiply both sides by it, again, I cancel these two out, okay? So that's that part. So I will cut that out and put that in there. All right. So, hold on for 1 second. Okay, last one. F of 1 is 3. F prime is greater than 2. That means that the slope of the line is greater than 2. There's 2 ways to do it. I did it 2 ways. What is the least value? So what I did was I used the slope. I said that this is the least slope that it could be. So if I did an equation, it would be 2 times x minus 1. So sometimes you're doing it where you're going, yeah, I know what I'm doing. So this would be y equals 2x minus 2 plus 3 is plus 1. And so if I look at 4, I get y equals 2 times 4 plus 1, which would equal 9. So 9 would be the least amount of value. I'm going to do this a different way. I'm going to tape this one on there as well. Or, if we look at this, the least value for this, if we do the mean value theorem, then what we are going to do is that I have to know that the derivative at C is equal to f of b minus f of a over b minus a. And I have one of those values. Okay, so I need to know from a to b here, I need to know f of 4 minus f of 1 over 4 minus 1. I need f of 4 minus f of 1, which is 3 over 3. And that has to equal f prime of c. So if I multiply by 3, I get 3f prime of c equal to f of 4 minus 3. So 3f prime of c is equal to f, plus 3. I need those erasable pens. F of 4. So f of 4 is going to be your c value. Or excuse me, f of 4 is what we're finding, and your c value has to be greater than 2, but 2 is going to be the lowest one. So 6 plus 3 is 9. So that would be the least amount that you would get. Okay, so there's two ways you can do it. You can look at finding the equation of the slope, but I think the calculus-y way to do it would be that way. So you want to look at those values. Okay. All right, so I will add that on, and then Mark did that one on the video, so I am not going to rewrite that as the video because it is in the video. So, all right, let me come back to here. Have a good night, and we will see you. That's just my video camera. We will see you later. I'm going to put something over here to the back of my right shoulder here, something on the wall, because that's kind of plain Jane right now, and I don't want to do any of the backgrounds, but we'll figure it out. All right, so hopefully this, you have any questions, shoot me an email or schedule a Calendly time with me. All right, I'm going to then post probably the Riemann sums and the integrals after this video. Signing off. Going to bed.